Good morning, everyone. Is my voice audible? Is my voice audible? Okay. Uh, okay. So sorry for the confusion. But I said in the class I told that I'll be starting at 9. But yeah, but it doesn't make. Uh, I mean, I can't start with very less. But yeah, I'll maybe start now so that others can catch up at 9:30. But yeah, I confirmed multiple times. But yeah, anyway. So maybe we can spend the extra maybe 5 minutes to understand if you have any doubts as such before we move on to today's class. Anything that came into your mind after the class that you are not able to ask to me. So those kind of doubts you can ask if you have anything, or else you can get started with today's class. So maybe we'll wait till 9:30. But I have a meeting at 11, so I have to anyway go at 11. So I'll try to finish as much as I can today. Maybe tomorrow and day after tomorrow we can make up for the time we lost today. That's why I thought maybe till then you can, if you have any doubts, you can ask. But yeah. That's what I told, right? So the number of rounds depends on the number of companies. So whatever I said was very generic. So whatever I said will be true to maybe Uber, Google, Microsoft, those kind of things. But yeah, even there, some candidates have more rounds, some candidates have lesser rounds. So yeah, you need not worry a lot about the rounds. But whatever that will be asked in the round is what it matters, right? So yeah, there is no fixed number for that. I think if you are really good in coding round, they can even skip two rounds. So those kind of things can happen depending on the HR and how quickly they want people. But yeah, you get the idea, right? So it's not fixed. So why your number of rounds is not fixed for every company. I mean, it's not fixed for all the companies. Every companies have their own selection criteria. Is it clear? Like what I said? You can ask the. So I don't know how this works. So I am not really sure. If it is depending on the company, it can change. But since it's DS and algorithms round, if you have DS and algo round in those 3 rounds, then the questions will be something similar to code kata questions. Okay, I think can wait for some time. No, I disagree with that. So I got a person message saying that uh, if we can use a built-in function for everything, then what's the use of learning data structures? I agree and disagree. Agree to the fact that if the question is asking you to sort, yes. But what if you have to do something which is not a normal sort, maybe a mountain kind of a sort. Suppose you sort everything like a mountain kind of a thing. You get what I'm trying to say. So those kind of things, say you want to sort the array something like this, or you want to sort the array something like this. So how do you do that, right? So you can't use built-in functions, right? So yeah, I disagree, but yeah, data structures will be there for a really long time. At least our generation will have to use this. The reason being, everything that is built today, right? Say React or something. So behind the scenes, everything will be like normal data structures and algorithms. Even database, everything, right? Behind the scenes, it will be just hashing or something. You can say I can use the database without even knowing what is hashing, correct? But that is just one part of the engineering, right? So you are just a consumer of the algorithm someone has built. What if you are working in the AWS itself? What if you are the person who is developing the database? So you need to know what is hashing there. So yeah, uh, not all jobs need that. I agree, but knowing a data structure and knowing data structures and algorithms and how a built-in function is working behind the scenes will make you a better engineer. It will not be useful every day, but it will be useful when it's useful. So yeah, I myself have faced that. At least in the past 2 years itself, I have faced that. So if you have more experience, if you can have someone who is really experienced. So a person who is really good in DS and algo and knowing what is happening behind the scenes will, not just DS and algo, right? Even compiler or something, knowing how something is working behind the scenes will be handy at times when no one knows what to do. That is what is needed, right? So if 10 people can 10 people can do same thing, then yeah, it's fine. But if there are 10 people and those 10 people don't know how to do, that one person is the one who is going to solve it. So yeah, that's how I see it. But yeah, as I said, right? So I see DS and algo as an art. So art is an abstract form. You can see it however you want, or you can perceive it however you want, right? But right now, unfortunately, this is the only way. I mean, this is one of the way to get and work with bright minds. So yeah, in interview process, algorithm represent. Um, there are many ways to represent. So the question is, please ask the question in everyone so that I will not read out the question. Right? So yeah. Uh, Okay, so the question is, in interview process, algorithms represent either step-by-step process or anything, right? So as long as it can be even a proper communication also. You may not write or show or draw or anything. The thing is, as long as whatever you say is being understood by the person, by the interviewer, that's called an algorithm. As simple as that. So you have to say on approach. You can either draw it or you can either write it in text format. You can just communicate it verbally. So whatever you do, as long as the other person is able to understand that, then it's an algorithm. That's it. At the end, not at the end of the interview, but halfway through the interview, the interviewer should understand what you're going to do in the next half of the interview. Okay, so we'll wait for a couple of minutes. If you have any doubts, you can ask. Is the so someone said that there is some noise from my side. Is it better now? Okay. Okay, there are already 24 participants. I saw somewhere around 40 yesterday. So yeah, we'll have a number, maybe 30. After 30, we'll start the session. Or 9:30, whichever is earlier. Okay, I think we can get started. So yeah, good morning everyone for people who joined. So there was some issue. So the class was supposed to be started at 9 a.m. But I think the portal was not updated. So yeah, I think we can get started. So yesterday I just gave a quick recap on what we saw yesterday. So yesterday we just saw what is we just had a non-technical session where we understood what is required from an interview. So yeah, so from today there'll be technical session. So yeah, so I'll be breaking in between whenever you have doubts. So in that portion, if you have any doubts, please do clarify as early as possible so that the doubts does not pile up on one on top of the other, right? So yeah, so everything will be building on one another. So yesterday, if you remember, right? So yesterday we saw during an interview, the interviewer expects a efficient algorithm from you, right? Efficient or optimal solution from you, right? But yesterday we just told that we'll be saying it today, which is given a set of approaches. So every question will have a lot of approaches, right? Maybe for example, 10 approaches, right? So the 10 is not fixed, right? So if someone can come up with a new approach and that will also be counted. So you can't say this question can solve only by these two ways, right? So yeah. So there'll be some 10 approaches. For example, we'll take that number. So out of these 10 approaches, what are all those approaches which are efficient, right? So one thing I wanted to call out is you can't say this is the best way to solve this problem, right? So there can be multiple ways which are good ways to solve the problem, right? So what we have to do is we have to clear out very bad algorithms and very bad algorithms on the good ones, right? And so that we know which is good and which is bad, right? So the class started at 9:30. No, only I started. So yeah, so the idea is to somehow say, okay, given a set of approaches to solve a problem, whether we have to say whether this approach is uh, an efficient one or not, right? So yeah, uh, so that is why we use time complexity, right? So we have to understand what is time complexity, right? So yeah, so let's just take an example, right? Say there is a question on the internet. right? So say there's a question on the internet, and say A is you and B is your friend. Okay, so A is you and B is your friend. So you are having a very old machine, and your friend is having a new machine, right? So what you're going to do is you say you are having one compiler, right? So you are taking this code, you are having the question and you're having a code for it as well, right? So what you say to your friend is you take this code and run it, right? So you take this code and run it, same code. I'll also run the same code, right? So we'll give one input and we'll be obviously getting the same output, right? Because the same code, same compiler. So yeah, so same input, same output is going to come. So that's not the issue. The thing is, what you're saying is compute the execution time of your program. So that's the ask. So you're going to compute the execution time of the program. Your friend is also going to compute the execution time of his or her program, right? So what is the execution time of a program? The moment from where you enter the input to the moment till the output is shown, right? Say if you're logging into a site, so you write your email ID and password. So you click sign in, right? So from that moment of clicking sign in to the moment of logging in properly, right? Completely loading the next page, that is called the execution time of the logging feature, right? Same way, in this case, the moment you give all the input and end the input from that moment to the moment till you get the first glimpse of output. So that is the execution time, right, of a program. So what you're going to do is you're going to say, okay, you compute the execution time of your code and my code and we'll compare, right? So just to give an idea, you're having a very old machine, your friend is having a very state-of-the-art machine, right? So what is happening is you compute the execution time. So after computing the execution time, there is a shock. The shock is your code ran in 1 second, right? Your friend's code ran in 2 seconds, right? Uh, but you are confused because you are having a very old processor, old RAM. I mean, lesser number of memory available. But your friend is having a new processor and he's also having a very uh, more gigabytes of RAM, right? So what is happening here is you are just confused. So ideally, your friend's code should have ran faster because he's having a very good system. But or at least it should have been same as 1 second for the same input and same output, right? So, but the thing is, it is taking more time. So now you guys are confused, right? Um, so what you do is you just analyze and understand why that happened. Then only you understand that when you ran your code, there were a lot of processes running. I mean, there was nothing running behind the scenes, meaning your code was the only code which was running, right? So your code was the only code which was running, right? So which means the entire processing power and the entire RAM was available to this piece of code, apart from the OS and other related things, right? But when your friend ran his code, he was running a video editing software behind the scenes. He was running some Google Chrome tab. He was playing some songs. He was playing some game, and he abruptly cut that game and came here. So you get the idea, right? So most of the processes went to this guy. All these background processes, and very few process power was available for to execute this. Okay. So which means that there were a lot of resources which were already being used and the number of resources available, the amount of resources available for this code was very less. So that's why it took 2 seconds. Meaning the same code, right? The same code is giving 1 second in your computer and 2 seconds in your friend's computer. And this 1 second from your computer is not fixed, right? So if you run something behind the scenes, there'll be more time. So what I'm trying to say here is you can't say that, okay, this code is going to get over in 1 second. This code is going to get over in 2 seconds, right? The reason being the same code can take different time depending on where it is run and when it is run, right? So why when there can be multiple processes, so that is fine. After some time all the process can be closed and you get the right, you get the idea, right? Which means whenever you analyze the code, right, whenever you analyze a code and you analyze whether it is efficient or not, right, whenever you analyze whether it is efficient or not, the efficiency should be dependent only on the piece of code, correct? Because that's what you're trying to find out. But here this efficiency is dependent on where it is run. So it is dependent on the environment at which it is run, right? So which is not the correct way, which means the second or time is not a correct way to understand the complexity of a program. Why means this time is dependent on the environment at where it is run. So what is environment here? The machine where it is running and the time at which it is run, right? So the machine and the state of the machine, what is the background of the machine, everything is dependent on this. So this is not going to give a clear idea on whether this piece of code is efficient or not, right? So first thing is to understand the efficiency of a code, we can't use time. The reason being, it is dependent on the environment at which it is run, right? So this is the first part, which means we can eliminate time for now. So, so is everyone clear on why time is not a very good way to understand the efficiency of a piece of code? Right. So now the issue is we know that time is not a very good way. So what is one thing which is not going to change dependent on wherever it is run, right? So that is the part which is going to give the pure efficiency of the code, right? What I mean by pure, that efficiency will be dependent only on that piece of code, right? So what is something which will not change depending on the piece of code, right? So let's just take one example, right? Say you have a for loop. So this is the only piece of code. Say you have a for loop. N is the input to this program. N can be anything. You can give N as any input, right? So this for loop is going to run from 1 to N. This for loop is going to run from 1 to N, right? And say you're not doing anything, right? So you're just not doing anything here. Just a dummy for loop, okay? Do nothing, okay? So just a comment and it's not doing anything, right? So how many iterations or how many executions this piece of code will go through? Right. So this piece of code will go through n iterations, correct? Because you're starting at 1 and n is going till n, right? So this is dependent on the n, but if you if n is the input, so this will take n iterations, correct? Will the number of iterations change based on the computer where you're in? Say in a supercomputer, will the number of iterations be lesser or more? No, right? So that's why, so they thought of using this as a piece to understand the efficiency of a code, right? Why this is a better way to understand the efficiency? Because this is dependent only on the piece of code and how you write, right? It's not dependent on where it is run, when it is run, those kind of things. It is only dependent on how you write. So what we are doing is we are separating out hardware from efficiency. So in our previous case, we also considered hardware as one piece of efficiency, right? Because where it is running. So what we are doing is we are just taking out hardware from this efficiency, meaning the efficiency is always dependent on the software or the code you write, right? So yeah, so that's the first thing. That's the first thing about time complexity, meaning the complexity will be dependent only on the number of iterations the code is going to go through, right? So yeah. So this is the basic idea of a time complexity. So yeah, any doubts in this? Okay. So in our previous case, we had the system at where it is running and what is the processor, how much RAM, what is the what are all the processes that are running behind, those kind of things, right? So that is nothing but hardware, right? Which means efficiency should not be dependent on hardware, because if you are just trying to find out the efficiency of this piece of code, right? So whatever you're trying to find out about something, it should be dependent only on that something, not on some other background thing, right? So in this case, the number of iterations this code is going to go through is not dependent on the hardware, right? Whether the hardware is, you have super good hardware or you are a very bad, very not so good, not so state of the art machine, the number of iterations is going to be n anyway, right? So which means the efficiency of the code piece of code is going to be dependent on the number of iterations it is going to go through, right? So number of iterations or number of executions. So here, since we are using for loop, we call it as iterations, but usually the number of executions, right? So here, this piece of code will go through n executions, right? So this n execution is independent of where it is run, when it is run, right? So yeah, so this time complexity is going to focus only on the number of executions in a piece of code. right? So yeah. Okay. So if you understand this, then so now we'll see how to represent time complexity, right? So how do you represent time complexity? So you need some form of representation, right? Say if someone is asking what is the efficiency of a code, how do you say that, right? So there are many ways to represent time complexity. In the interest of time, I'll just say the most uh, common way to represent it, right? So this is called big O. Okay. So big O, and what is this big O, right? So big O will give the worst case time complexity of a piece of code. So what is the worst case time complexity, right? Yeah. So what is the worst case time complexity? Say you're designing Netflix, right? Say you're designing Netflix. You know that it will be having multiple traffic pattern, right? So what I mean by traffic pattern is during the weekdays, maybe there'll be 1 million people who are online at a given time, right? So in weekdays, there'll be 1 million people who are online at a given time. But during weekends, since it's a weekend, there'll be 10 million people who are online at a given time, right? So when you're designing a system for Netflix, uh, you design for do you scale it for 1 million people or 10 million people? Meaning you'll design it for to handle 1 million people at a given time or 10 million people at a given time, and why? It's obvious, right? So you don't want it to break during weekend. Meaning, why do you do it for 10 million people? Because that's the worst case, right? That's the worst thing that can happen to the system. So if you are prepared for this worst case, then you will be obviously prepared for this weekday also, right? So only thing is you might waste the resources, which is fine. So a site going down versus wasting resources, I'll always prefer, wasting resources, right? Because it's going to only hurt you. If the site is going down, it's going to hurt the entire product, right? So yeah. So what I'm trying to say is this big O is something like this, right? So what is worst case in a piece of code, right? So in a system, it is something like 10 million people hitting at the same time. But in a piece of code, what can happen is for some input, the number of executions will be less. For some input, the number of executions will be more, right? So the input which is going to take the maximum efficiency, right? I mean, which is going to take the maximum number of execution and is least efficient among the various input. So that input is called as worst case input, right? So for example, everyone knows a sorting function, right? So we'll not go into how the sorting is going to happen, right? So say you're given a array of numbers, okay? So you would have used the built-in sort function. If not, there is a built-in sort function in sort. I mean, in most of the languages, right? So what does the sort function do is, begin the sense it will be intelligent, right? So first it will see whether it is already sorted. So if it is already sorted, it can finish the sorting in n iteration. How? Because first it will see whether it is already sorted. So how does it check? It will start from the first index and see whether that guy is greater than the previous, greater than the previous, greater than the previous till the end of the loop. So it'll take n minus one iterations, right? So this is the best case for this, right? So this is the best case for this because the array is already sorted, right? But this big O does not worry about this because it's the best case. So what if the array is unsorted, right? How many iterations it will take, right? So we'll not go into the details. Say for bubble sort, it will take n square iterations, right? So there'll be two loops and other things. You do not worry about how we got this n square and other things, but you get the idea, right? So worst case is if the array is not already sorted. So if the array is not already sorted, then it's going to take n square iteration, right? So Big O will worry only about this, and that's why Big O is famous because you get the idea, right? Once you say Big O some complexity, then you need not worry about everything, right? You need not worry about other things, right? Because that's the worst case. So if that's the worst case, then the best and average case will be inside it already, right? So yeah. So there are other ways too, which we'll not go into this because it will be more theoretical. But for practical point of view, Big O is the one which is used across, right? So yeah. So Big O is one way to represent the time complexity and the most popular way. Why is it popular? Because it gives the worst case time complexity, right? So yeah. So any doubts in this? Okay. So what we'll do now is, so now we understood what is time complexity. I mean, we understood what is the criteria with which we'll understand the efficiency of a piece of code, which is the number of iterations or execution. Second is how do we represent it, right? So now we'll come to time complexity. So what is time complexity? Time complexity says how efficient a piece of code is, right? Right. But one thing to understand is time complexity is not a golden rule. What I mean by golden rule is, say you are given with a question. So you can't say this solution is the best solution available in the world. You can't say that, right? Why means with the same number of executions, there can be 20 different approaches, right? So with the same number of executions, there can be 20 different approaches. So among those 20, you can't say which is best, right? Because everyone is going to take almost a similar kind of executions, right? So the time complexities idea or time complexities responsibility is not to find the best, the best algorithm for any piece of code. It's not its responsibilities. So what are this whatever what is its responsibility is? Say you have 100 ways to solve a problem. In that 20 ways, take almost maybe x iterations, okay, and another 30 takes why I'll say why we are doing this approximation and not equal to, okay, y iterations, and maybe the next 50 takes z number of iterations or executions, right? So here x is less than y is less than z, right? So what is time complexity going to do is, okay, I have three different complexities x, y, and z, right? Among these two, uh, time complexity will say don't even see these 80 things. So what you want is these 20 approaches, right? So time complexity's responsibility is not to give the best, but give the bucket or give the grouping which is best. So the time complexity's responsibility is to give the grouping which is best. So what I mean by grouping here, the time complexity of the approaches we have, right? So it will say, okay, boss, X is the best complexity for this piece of code, right? X is the best, I mean, X is the worst case complexity for this piece of code, right? And that is the most efficient. But among these X 20 approaches you have, I don't know which is better, right? You choose among these 20, whichever is better, right? That depends on your use case, right? So sometimes you can use one, sometimes the other will be useful. It depends on your use case. So time complexity will not even mess with these 20. So what it will say is, okay, X is the best complexity you can get for this piece of code. But among these 20, I don't know what is better. You choose after. So time complexity is going to deal with a very high level, meaning it is just going to, segregate all the approaches into fewer buckets, right? What I mean by bucket, it's more like grouping, right? So X, Y, Z are grouping. And among those grouping, it is going to say, okay, this grouping is the best grouping. But among the approaches inside the grouping, it's your responsibility, right? It's your responsibility to see which is better, right? So that's why in an interview, they'll fix this X. So say for a given question, they know that X is the best complexity available, right? But there can be 250 approaches or even million approaches. So they don't care. As long as whatever so they know the X is the best complexity, right? So as long as you come up with some approach, right? And if you can justify that X is the complexity of that approach, then they are fine with that solution. Meaning it's not like a textbook kind of a solution. Say the solution which interviewer is thinking is the only solution which you have to say. No, it's not something like that. You can come up with any solution on the spot, but as long as you can convince the interviewer that the solution you have is the complexity with which they are expecting, then they are fine with the solution, right? So that's the idea behind most efficient. You should not give any approach. You should give the efficient approach, right? So that's what I said. So you can't give Y or Z in an interview. If you give Y or Z, the interviewer will say, can you do better, right? So he'll not even let you code these Y or Z unless you come up with some approach and justify that that approach you come up with is having the complexity yes X. He will not let you code, right? Meaning, first you come up with some approach, then you justify that the complexity of that approach is some X, which the interviewer is thinking, and then only you could, right? So this is the order in which it should go in an interview. If you are not following this order, the interviewer will try to make you follow this order. But if you are directly jumping into code or something, then it's a red flag for you, right? You know the reason, right? So why directly coding is not a very good way to approach any problem, because you'll be coding a lot of things again and again. Right? So yeah, so this is a basic idea. So everyone understood the responsibility of time complexity, right? So time complexity is not like a silver rule or something, right? So it's just, very high level grouping of good and bad. So any doubts in this? Like, what is the responsibility of time complexity? Right. So keep this responsibility in mind. After some time, you'll be definitely having some doubts, which I'll clear. Okay, I'll try to clear. But yeah, this understanding this responsibility is, important, right? So time complexity has two rules. Okay, so two rules. The first one is actually the most confusing one. Second one, I think you will be able to get it. But the first one is the most confusing one, right? So first, I'll just come back to the rules later, but it has two rules. Okay. So the same thing. Now you and your friend are somewhat clear on what is time complexity, right? Because you have understood how to denote and how to, those kind of things. So what you're going to do is, in this case, in the previous case, you shared the code itself. But in this case, you're just seeing one question on the internet, and you guys are, saying that you code your own solution. I'll code my solution, right? So you say, I'll code my solution. Your friend is going to say, okay, I'll code my own solution, right? So what is happening is same question, but the only thing is the input will be same, right? So the input will be same for both of you, right? So what is going to happen? So you have some question, you take that question, you send the same question to your friend, and you are going to write your own code. Your friend is going to write his or her own code, right? So yeah. So say this is the code you write, okay, and this is the code your friend is going to write, right? So this is C1, this is C2, but the input is same, right? So what you are doing is, for you the input is n, okay. So for a friend also the input is n. So what you are going to do is, you are going to start a for loop. I will not go into what the question is, but what you are going to do is, to solve that question, you have a for loop from where I starts from 1 and goes till n, okay, not up to n but till n, including n, okay. And yeah, you do something here, we will not worry about this, right? So what your friend is going to do is, he is going to start a for loop, right? He's going to go from 1 to n. But what happens is, he starts the for loop and ends the for loop, right? He again starts the for loop and again goes from 1 to n, right? And he does something here, meaning he started a for loop, but he forgot to remove this piece, right? So that's an empty for loop, but he forgot to remove this piece. But both of you have solved the problem. So you will be giving the same output, right? For if the input is same, the output will also be same, meaning that both of your code are working solution. But it's just that your friend has missed one extra for loop, and he forgot to remove that piece, right? So yeah, so this is what is happening. So in your case, how many iterations your piece of code will take? Right. So your piece of code is going to take n times, right? So n iterations. Okay. So how many iterations your friend's piece of code is going to take? Okay. So just to clear, this for loop is starting and ending here. The another for loop is not inside this for loop. So this piece is going to take n, and this piece, right? This piece is again going to take n, correct? So it's n plus n to n. So is everyone clear on how we got to n and why it's not n square? If this for loop had been inside this, then it can be n square. But since both are independent, this is 2n, right? So yeah, so your code is going to take n iterations, your friend's code is going to take 2n iterations, right? So yeah, so what is the first rule of complexity is saying is, so the issue is here, the issue with this is, so how do you represent your complexity? You will say O of n. So why O of n? So if n is 1000, this code is going to run 1000 times. It's not more, it's not less. So the worst case is O of n, right? So worst case is n iteration, so it's O of n. But what is time complexity saying is, uh, say you have O of n here. Your friend is going to take O of 2n, right? Someone is going to take O of 2.5n. Someone is going to take O of 2.25n. Someone is going to take O of 3n. Someone is going to take O of 5n. So you get the idea, right? So for the same piece of code, there can be O of n, O of 2n, O of 3n, something like that, right? Say there are 100 ways to solve this problem, right? So everything will be in its own bucket. Meaning, in our initial case, we were grouping it into X, Y, Z, right? But here there'll be 100 variations: X1, X2, X3, X4, X5, X100, right? So ideally, this time complexity is not at all helping us much, correct? Because only if we have lesser number of groupings, say if you have 3 or 4 number of groupings, we can compare. If you have 100 groupings and every piece of code is in its own grouping, then it's not going to help us much, correct? So what is time complexity saying is, you can remove the constant terms from the complexity, right? So so if the code is going to take one iteration, two iteration, three iteration, four iteration, five iteration, six iteration, everything will be represented as O of n. So 1n, 2n, 3n, 4n, 5n, 6n, everything will be represented as O of n. Right? Why this is important is, then what will happen is all these codes will be grouped into O of n bucket. Correct? So among these 100 pieces, then you can see which is better, right? Among these 100 pieces, you can see which is better, right? So yeah, so idea is, the lesser the number of groupings you have, the easier it is to understand which is more efficient. If everything is in its own grouping, then it's going to be difficult, right? So this is one justification, right? This is one piece, because since the time complexity wants to find a group of good code, because there can be multiple ways to attain the same complexity, right? So since you want to attain group of good code, then so that is why time complexity is removing the constant terms from the number of iterations. So if someone is taking 10 n iterations, this will again be, the 10 will be removed, because this 10 is independent of the input, right? So if n is 1000, 20,000, 30,000, 40,000, this 10 is going to be there. So 10 is a constant here. So they usually remove this constant and represent it as O of n, right? So yeah. So that is the first assumption in, that is not the first assumption, first rule in time complexity, meaning you have to remove the constant terms, right? Right. So okay, so why O of 2n is equal to O of n, right? So as I said, right, say you are writing, you are writing O of n, your friend is writing to O of 2n, someone is writing O of 3n, then there'll be 100 ways to understand this, right? So one thing is, it's difficult to group all these items, so everything will be in its own group, right? Because everyone is different. So how do you say which is efficient? So then you have to go through everything and understand, right? And second thing is, time complexity is not something like uh, is not something very low level. So what I mean by low level is, let's just take one example to understand this, right? So let's just, this example will give you an idea on in what level time complexity is going to do the grouping, right? So in what level time complexity is going to do the grouping, right? Say same, right? So A and B, right? So A is your friend, A is you, and B is your friend. Same thing, but here you're writing a code, right? I is going to start from 1 to n, right? And you do something, right? So n is the input, and you get some output. Same, n is the input, but your friend is writing a different code. So in this time, he is writing a nested loop, where I is going to go from 1 to n. J is also going to go from 1 to n, right? And he or she is doing something here, right? So let's just not worry about what they're doing here. Yeah, same input n. So how many iterations your code is going to take? So this is O of n, right? So how many iterations your friend's code is going to take? Okay, so this is n square, right? So let's not bring the complexity here. Let's just put the number of iterations here, right? Okay. Okay. So to understand time complexity, so time complexity actually, actually will not say n square is equal to n. right? Because this n square is dependent on the value of n, right? So to understand this, let's just take an example. Okay. Say n is 10 power 5. Okay. So n is 10 power 5. Okay. And let's just try to put it into try to fix some time. So usually it's not a very good way to understand this with the time, because you know the reason, right? So time is dependent on multiple factors. But to understand uh, how big n square is compared to n, I'm just doing this as an exercise. Okay. So n is 10 power 5, and your machine can do 10 power 5 iterations in 1 second, right? Your machine and your friend's machine can do 10 power 5 iterations in 1 second. Okay. So n is 10 power 5. Your machine can do 10 power 5 iterations in 1 second, right? So in how much time, what will be your code's execution time? So in how much time your code will, finish? So n is 10 power 5. So here it will go from 1 to 10 power 5, and your computer can do 10 power 5 iterations in 1 second, right? Which means this entire piece of code can be done in 1 second by your computer, correct? So yeah, so your code is going to take 1 second, right? Okay. So how much time your friend's code is going to take? Okay. So let's just do it mathematically, right? So that we are not, everyone is in the same page. Okay. So you can do 10 power 5 iterations in 1 second, right? So how many iterations? So if n is 10 power 5, what is 10 power 5 the whole square? 10 power 10, right? So if you can do 10 power 5 iterations in 1 second, in how many seconds you can do 10 power 10 iterations? So that is what we are trying to find out, correct? So it's just cross multiplication, correct? So what is 10 power 10 by 10 power 5? So if the base is same and the power is changing, what is the rule in dividing them thing? So it is 10 power 10 minus 5, right? So your friend's code is going to take 10 power 5 seconds to finish, right? So what is 10 power 5 seconds, just to understand? So it is 27 hours or 28 hours. Okay, so you can Google it, but yeah, 10 power 5 seconds is close to 28 hours. Meaning, if you start a program with your piece of code, it's going to finish it in like this. Okay. If you start now, your friend's code is going to finish tomorrow afternoon, right? So you get the idea, right? So time complexity is actually dealing at this level of, at this height. Okay. So at this height. So what is time complexity saying is, okay, boss, this is O of n and this is O of n square, and clearly A is better than B. So you take O of n as the best complexity for this piece of code. Okay. So B is not a very good thing. Why? Because B is going to take 28 hours to finish if the input is very high. Right? Depending on the input, the time is going to change. But the input is very high, it is going to take hours and days to finish. Right. So time complexity is actually dealing at this level of abstractness and this level of height. Right. That's why it's okay to ignore the constant terms. Right. So if someone is writing in two n iterations, it is going to take 2 seconds, right? If someone is writing in 10 n seconds, it is going to take 10 seconds. So compared to 27 hours, 10 seconds is nothing, right? So what is time complexity saying is, okay, I'm not going to give you this 1 second code for you. What I'm going to do is, I'm going to segregate these two, right? I'm going to say, okay, I'm going to segregate very bad piece of code from good piece of code, right? And whenever you say time complexity, it's for a very high volume of input, not like n equal to 2, n equal to 5, those kind of inputs, right? So even when n equal to high, A is going to succeed in many other ways, right? Compared to B. So among this A, there can be 1 second solution, 5 second solution, 10 second solution, depending on the environment, depending on the what you're trying to do, depending on what you're trying to process, etc., etc. So among those, you can do those optimizations depending on whatever you want. That's not the responsibility of time complexity. Time complexity is going to say, okay, compared to n and n square is lower. So you go with n. So in an interview, if the expected is O of n, and you are coming with O of n square, the interviewer will say, can you do better, right? But the interviewer can be having a 5n solution, say for example, 5n solution. But even if you come up with 10n solution, they are okay, because 5n and 10n at the end of the day, you ignore this constant and become O of n. So they don't want this kind of optimizations in an interview and even in real world, right? Because it is dependent on a lot of other factors. They just want this level optimizations in a very high level, right? So that's why we don't do a lot of things in time complexity. Time complexity is going to segregate, okay, this is O of n, this is O of 2n. I mean, this is O of, no, this is not equal to O of n, this is much more greater than O of n, for example. Then you can segregate this. So that's the reason we don't care about the constant terms in complexity. So we remove the constant terms, right? Even now, if you are confused, the best way to understand this, to forget that time complexity is not the one solution. I mean, one thing which is going to solve all your problems. No, it is just one way to reduce the number of problems you have. After that, it's your headache. So if you have like it will just reduce your headache. It's not like one tablet to cure your headache, something like that, right? So yeah. So the first thing is you remove the constant terms from time complexity, right? So why do you remove the constant terms? So that you can group some 100 ways in a single way. So if you come up with 10n solution, if your interview is using 5n solution, you can group these two into O of n, right? So it's easy to handle, right? So it's easy to carry around, right? So if everyone is having different complexity, then it's not going to give you any it's not going to give you, it's not going to benefit you, right? Then every piece of code will be having multiple complexities based on multiple the way you implement, right? So as long as if you can implement in O of n, it's okay, right? So this is the optimizations we are looking for, not this level of optimizations, right? So this is the reason why we remove constant terms, to keep it simpler, right? So yeah. So any doubts in this? So is everyone convinced that whatever we are doing is good for us, meaning it's going to make our life simpler, like removing the constant terms? Okay, so I didn't understand one question, which is there any website to view time complexity in live? Time complexity is different on how you code a solution. So I don't think so. If you are saying, okay, given a piece of code, it will say what is the time complexity. I'm not sure, but yeah. Yeah, that's a very good question. I'll come to that, right? Okay, so if there are two loops separately, then it will be 2n iterations. Then you use this rule saying that, okay, 2n is not, 2 is a constant term. So it will be said as O of n. So both in this case, both your code and your friend's code is O of n, because your friend took only 2n iterations, right? So yeah. So both these are to O of n solution. You got it? Okay. So this is the first term, this is the first thing, which is you remove the constant terms from complexity, right? This is the most difficult to convince people, because usually we have been quantifying things, right? So in our real world, we quantify things, but here it's not any quantity. That's why it's not having any units, right? So what I mean by quantify is, say, 100 grams or 1 liter or something which is quantity, you can see it. But this is something which you can't see it. So it becomes a little difficult to understand this. But yeah, once you cut some slack to TC, time complexity, saying that, okay, boss, I'm not like going to rely 100% on you. You just give me better things. I'll make sure after that, right? I'll take care of it after that, right? So yeah. So that's the main idea. So first idea is you remove the constant terms. Okay. Remove constant terms. Right. So second rule is, I'll just try to understand it. I mean, I'll try to make you guys understand. Say you have a long piece of code. Okay. The same code, but with this code, you are just dividing it into different parts, right? So the first part is going to have n square complexity. Second part is going to have n cube complexity. Third part is going to have O of n complexity, right? So this is complexity itself. It can have 2n iteration, 2n square iteration. It can have 5n square iteration. It doesn't bother you because you have boiled it into complexities, right? So yeah. So same way, this n cube, right? It can have 3n cube. It can have 10n cube. So the first rule will remove these constants because this constant is not going to make your jobs easier, right? So you just consider it to be n cube. So you get the idea, right? So first part is going to have O of n square, right, complexity. Second part is O of n cube complexity. Third part is O of n complexity, right? So among these three, part one, part two, and part three, which part is slowing down the program? Which part is slowing down the program? Right. So part two is slowing down the program because it has the worst complexity, right? So compared to n and n square, n cube is worse, right? So what is time complexity saying is, so the total time complexity is actually O of n cube plus n square plus n, correct? But what is time complexity saying is, okay, boss, I don't want all these details because it's going to get complicated for me. Because someone can do it in n square plus n by 2, or n by 2 will not come. Okay, someone can do it in n cube plus n square, right? They'll not even use this extra n. Someone can do it in n cube plus n. They'll not even use this n square, right? So there'll be a lot of combinations. So what is time complexity saying? Okay, I don't want to complicate things. What I want is the piece which is going to slow down the entire thing, which means given complexity will with multiple things, you'll remove the smaller terms. So here, compared to n cube, n and n square are smaller terms, right? So this piece of code, the entire piece of code's complexity is only O of n cube. Why means time complexity is focusing only on this piece, which is slowing down the program, right? So time complexity is not dependent on other things, right? Which means to generalize this, time complexity will remove the smaller terms from the complexity, right? To make it easier. You get the idea, right? So or else you'll be facing the same issue because someone can solve it in n square plus n, sorry, n square plus n cube. Someone can solve it in n cube plus n. Someone can solve it in n cube plus n square plus n. So you get the idea, right? So all these will be having O of n cube complexity. Because at the end of the day, in all these, n cube is the one which is slowing down the program, right? So compared to n cube, n square and n is going to get over in very quick time. Say if n is 10 power 5, right? So in a previous case, 28 hours was more than very high than 1 second. But what is 10 power 15? 10 power 15 will be something like 10 power 15, 10 power 10 seconds will be something like years or even decades, right? So a decade is much more higher than 28 hours, right? So you get the idea, right? So this n cube and all is going to grow very faster, right? What I mean by faster is if you try to plot a graph for n square and n cube, n will be something like this, n square will be something like this, n cube will be something like this. So as they move along, the width will increase. So it will go something like this. It will be very close to this y-axis, right? So yeah. So that's why when compared to n cube, n square and n are very less, right? So it's like it comes free of cost, right? Because if a code can do n cube itself, then n square and n is not going to take a lot of time, right? So to make it simpler, you remove the smaller terms, right? So that's the reason we include only the smaller terms in the complexity. So you remove the constant terms, you remove the smaller terms. So these are the main rules in time complexity. Again, right? So you never ever compare time complexity and time because time is dependent on multiple factors. Time complexity is dependent only on the piece of code. So again, as I said, this comparison is just to understand what is the level of abstraction time complexity is doing, right? But you can never do this. You can never do this in real world because time is dependent on multiple factors. So how can you equate two things which are, so time complexity is a unit. So what I'm trying to say is you can't go and ask for 1 liter sugar, right? You can't say, okay, 1 gram sugar is equal to 1 liter or something. Yeah, you can melt and say, but you get the idea, right? So everything has its own unit. So time complexity's unit is this big O, right? Actually, it has no units, but its representation is big O. You can't equate two things because one is dependent on other. You can only equate two units only if these two units are dependent on the same factors, right? So since time complexity and time is not dependent on the same factors, you can't equate it. You get the idea? It's more like a gram or kilogram itself. It's a different unit itself. It's just that it doesn't have any unit, but it's just a separate representation itself altogether. Like if it's a liquid, you say liter, right? So if it's a solid, you say gram or kilogram. Same way for complexity, you use big, something like that. So you can't equate these two. Am I making it clear? So yeah, so it's not like how many seconds each piece is going to take. There is no seconds at all, seconds talk at all in this complexity. It's just the number of iterations, and you try to come up with the number of iteration based on the input, and based on the input, if everything is having uh, a similar kind of iteration, then it will be same complexity, right? Because everything is more or less the same, right? So what you have to do, ideally do, is come up with the number of iterations in the piece of code with respect to input, right? With respect to input, if input is n, you have to come up with the complexity based on this value n, and based on this value n, you have to decide whether you can combine these two or not based on the rules you have, right? So that's how it is going to do. Is it clear? So equating time and time complexity is not is going to only cause more confusion because those two are different ideologies altogether. So we'll see. So given a piece of code, if you don't know what is even happening, we have some exercises to understand how to find time complexity. But yeah, so for now, if you are clear on these two rules, why we are doing these two rules, then it will be easy. Right. So yeah. So ideally in other courses, they just say, okay, use these rules. You don't ask why. But if you understand why we are doing this, then again, right? You can use a sort function without knowing how sort is working. But if you know how a sort is working, you'll be better engineer, right? So yeah. So same thing. So if you know why we are doing this, then yeah, you'll be a better engineer when time arises. Right? So yeah. Okay, so any other doubts in this time complexity? So with this theoretical part of time complexity is over, I just have two more things to call out before closing it. But till this point, is everyone clear? Great. So I just have two more things, and maybe we'll have a short break for 5 minutes before we move on to the exercise part of it. But yeah. So we just saw what is time complexity, and given a piece of code, you can kind of get it. But how to properly get it, how to use the rules we have, we'll see when we see on exercise. But yeah, coming back. So one more thing which I wanted to cover is constant time complexity, right? So what is this constant time complexity? Right. Say you have a piece of code which is going to run from 1 to 10 always, 1 to 10 always. So why do you do this? I don't know. But just for example, you just understand this, right? So this code is going to run always for 10 times, irrespective of the input. The input can be anything. This is going to run only 10 times, right? So how do you define the complexity of this piece of code, right? So that is why we have something called constant time complexity. So you can use the same rules. How can you denote this? So how many iterations this piece of code is going to take? It's not going to take n iterations, right? Because it's going to take only 10 iterations, irrespective of the input. So you can denote it as O of 10, or you can denote it as O of 10 into 1, right? So if you apply the rule 1, here 10 and 1 both are constants, but I'll remove 10, okay? So usually they represent this as O of 1, meaning what does O of 1 denote? O of 1 denote this code, the runtime of this code is not dependent on the input at all, right? Because if the input is n, if the complexity is having this n, then it means that it is dependent on the input value. So why is this O of 1? Because this is going to go 10 times always, right? Irrespective of whatever be the input. So this is called constant time complexity, and this is the fastest of all, right? You get the idea, right? This is the fastest. So when can this O of n come into picture, right? Say you have, say the question is find uh, given n, okay? So given n, find sum of 1 plus 2 plus given n, find the sum of 1 plus 2 plus dot 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 till n, right? So nothing but summation of n terms, right? So first approach can be, you can run a for loop. You can have a sum variable, which is initially 0. You can have a for loop, which is going to run from 1 to n. And the sum is going to be sum equal to sum plus I, okay? Sum plus I, right? So this is one way to do it. What is the second way to do is you can use mathematics, right? So this is nothing but a formula, right? So n into n plus 1 by 2, right? So this is nothing but a formula, right? So before understanding this solution, what are all the O of 1 operations in a computer, right? So printing is a O of 1 operation. Printing is a O of 1 operation. I think printing is not O of 1 operation, depends on the string value and all. So addition is one O of 1 operation. Subtraction is one O of 1 operation. Multiplication, division. Why addition is a O of 1 operation? Because if you add two numbers, these two are 32-bit numbers, right? 32-bit or 64-bit, you know the bit value of a number, right? So this is a constant term, right? So whatever be the number, if number is 1000, 10,000, 45,000, 65,000, 75,000, it is always 32-bit number, right? So addition, subtraction, multiplication, everything is a assignment equal to checking, if case, else case. So everything is a O of 1 operation because it is not dependent on the input, right? So when you come back for this question, given n, you are going to find summation of n terms, right? So one way is to run a for loop. Second way is to use a formula, right? So what is the time complexity of the first approach? What is the time complexity of the second approach? Right. So this piece is O of n because it is going to take n iteration, but this is O of 1, correct? Because it is just a multiplication and addition, right? So in this case, which is the better complexity? O of n is better, right? So this is what I call the constant time complexity. So whatever be n, the formula is same, right? So the formula is not going to change based on whatever be the n, right? So yeah. Okay, so this is what I wanted to call out. So this is called constant time complexity, right? So any doubts in this constant time complexity? Okay, great. So this is one part which I wanted to cover. Second part is space complexity, right? So whatever we saw was time complexity, right? So same rules, same everything, same number of things, but the only thing is the criteria in which you assess will be different, right? So in time complexity, we use the number of iterations or number of executions, right? So here it is the number of memory spaces taken, right? So why is the space complexity important, right? So time complexity is nothing but your processing power, right? So if you have a good processing power, the executions will be faster. So space complexity is nothing but how much memory you have or RAM you have, right? So that is also not unlimited, right? So you can't use memory just like that. That is also a limit for that, right? Say for example, you run a for loop from 1 to n, right? 1 to n. So this is O of n time complexity, right? So you don't do anything inside that, right? I'll just say why I'm saying this every time. You don't do anything inside it. The for loop just runs for some time, right? So what is the equivalent thing in the space complexity, right? Say the input is n, right? Say you have an array of size n, okay? You have an array of size n, right? So if n is 100, the array size will be 100. If n is 1000, the array size will be 1000, right? Which means how much memory this array is going to take if the input is n. Okay, so if the input is n, this is going to take n memory spaces, right? So this is called O of n. Say same representation, same thing. The only thing is it is dependent on the memory space it is going to take. And same way the rules are same. Meaning if you have four arrays, something like this, it's anyway again O of n, right? So if you have four arrays, again it's O of n because it will be O of 4n. And by rule one, you'll remove the constant term, so it will become O of n, right? So yeah. So the same rules, everything remains the same. Say, and the second thing is, say if input is n, okay. So in input is n, you have a 2D matrix, okay. 2D matrix of size n cross n. So n cross n. What I mean by n cross n? N rows and n columns. So what is the space complexity of this matrix? Right. So you have n rows, and in n rows, and in each row you have n columns. So it's n plus n plus n plus n times, which is n square, right? So this is O of n square, right? So the equivalent thing in time complexity is having a two for loop, right? Right. So something similar. Same O of n square. Say in a same program, you have a matrix and array. You can remove this by rule number 2. You can remove this plus n because the same thing, right? So if the array matrix is the guy who is going to, you know, there it was slowing down the program. Here it is something like the piece of code which is going to take more memory, right? So you'll just say it as O of n square memory or O of n square space, right? So yeah. So the same thing. The only thing is if it is number of executions, it's time complexity because it is dependent on the processing power. If it is number of memory spaces, it called space complexity because it is dependent on the storage power or the storage capacity, right? So yeah. So this is space complexity. Everything remains the same. The criteria alone changes. Any doubts in this? Okay, great. So what we'll do is with this, if you don't have any doubts, maybe we'll have 5 minutes break. I don't want to take away the break today. So yeah, we'll have 5 minutes break. We'll meet at 10:35. So you have water break or something till that time. And I'll also attach the feedback form. So you can fill in the feedback meanwhile so that you don't miss out the attendance. And I also get some constructive feedback. So yeah, I just copy the feedback form. So 10:35 we'll meet again. And we'll see some exercises I have attached here. So yeah, give me a second. Okay, I also given the feedback form. So please fill in the feedback form. We'll meet at 10:35 again. Okay, I think I can continue with the session. So there was one question saying if we store 1 to 10 in 5 arrays and having two numbers in each and storing the same numbers in matrix 2 into 5. Okay, so let's not take the numbers, right? So let's not take 1 to 10, right? Say 1 to 10 will be given as input, right? So 1 to 10 maybe uh, say that is the input k. Okay, so 1 to 10. So 1 to k will be given. So you'll be given k numbers till from 1 to k numbers, you'll be storing it in some number and you'll be given n arrays. And you have to store that the same k in n arrays, right? So here n is equal to 5, k is equal to 10. Okay. So how much memory space you are going to take? O of k into n, right? Kn, correct? So that's how you should see time complexity. You should not substitute numbers here, right? You get the idea? If you're not substituting numbers, and if you're just doing it for if you're just doing it for 1 to 10 for 5 arrays, then it's O of 1 because these 10 and 5 are not dependent on the input of the program, right? So whatever be the input, whenever it is run, it is going to be constant. So it will fall in the constant complexity. So unless it is input, it will be O of 1. You get the idea? Even if it is matrix, it will be O of 1, right? You get the idea, right? So how do you represent it? Is it clear? As I said, right? So it's not, so time complexity or space complexity is not going to nitpick you. So what is nitpicking? Okay, you are using one extra space. This is not right. No, it is just going to say, okay, boss, you are using some 500 GB here. This is using 50 GB. Why not use this 50 GB? Among these 50 GB, you have to say which is better, right? Or one can use 48 GB, one can use 60 GB. That's different. You get the idea, right? So that's why equating it into number is not a right way because number is well defined. Time complexity is an abstract concept, right? Okay. So the question was, what if we are going to store 1 to 10 in 5 arrays and 1 to 10 in 5 cross 5, I mean 5 row matrix, right? 1 till 10, likewise 5 times, right? So in both these cases, unless these numbers 1 to 10, 5 and all is not an input, in both these cases, the complexity is over 1, right? Because it is not dependent on the input, right? But if they say, okay, I'll give you the input, 1 to which number I have to store, so n, and in how many arrays you have to store, which is k, right? So if they give it as an input, then whether you store it in 5 different arrays or matrix, the complexity will be n into k, correct? So it is all boils down to, depending on the input, how the code is going to grow. If it is fixed for any given number of input, it becomes O of 1. You get the idea, right? So that's why equating it into a number is not a very good way. We just see it as input and output. That's it, right? Given an input in some form, how is the code going to behave based on the input? That is the only thing which is going to change. So these things are not going to change. So these are constant. So yeah. And usually the code you write will be dependent on the input, right? It will not be, you will not run a loop 10 times someday, right? Very rarely you'll do that. But how frequently you'll be doing something based on input, right? So yeah. Okay, so with this we'll start with, I hope everyone has filled in the feedback form. If not, keep a track of it so that even after class you can fill it. But yeah, so please do fill in. So I just have 3 examples. So I'll quickly go over these examples and yeah. So theoretically, whatever I wanted, I completed. So it just, understanding. So given a piece of code, if you don't know how to come up with complexity, this is a good way to understand. Right. So first example is this one. So this is a piece of code. What is the space and time complexity of this? Okay. Rand is a random number generator. You can just assume random as O of 1. Yeah, this piece of code alone is in C++. I haven't updated it, but yeah. Okay. So I got bunch of responses. First, we'll finish out the space complexity, right? So how many spaces this piece of code is going to take? So how many spaces it has? A, B, I, and J, right? So these are the four variables, right? It's not an array of something. These are four independent variables. So the number of variables going to change, or the number of memory spaces going to change based on the input n and f. Right? Whatever be the n and m value, these four variables are going to be there. So what is the space complexity of this piece of code? Right. So this piece of code is going to have O of one space complexity. Why? Because it is not dependent on the input anyway, right? So if you have an array of size n, then you can say it's O of n or something. But here we are not doing anything like that, right? So space complexity is clear, right? So first we'll see time complexity. Okay, so we have to see the time complexity, right? So first we'll see this piece of code. So you can just assume that this rand is O of one, right? So this piece of code is O of n, correct? And this piece of code is going to be O of m, right? So can I just say that this piece of code is O of n? Okay. So I will just try to get the total executions, right? There are the n plus n and m executions. So what if m becomes n square someday, right? So if m becomes n square, what will happen? N plus m n square. So what is O of n plus n square? So you remove the smaller terms. So it is O of n square, correct? So you told that it's O of n, but it's O of n square, correct? So which means O of n is not a very good way. So why O of n is not a very good way to represent this? Because you're assuming that m will be always smaller than n, but nowhere it is given that m will be always smaller than n. M can be n power 10 also. You never know, right? Again, the same way, same way, you can't say it as O of m. The same reasons, right? N can become n square or n cube someday, right? So what is the best you can say here? O of n plus n. You can't optimize further, right? Because you don't know the value of n and m. If you know that m is always smaller than n, then you can leave it as O of n. If you know that n is always smaller than m, then you can say it as O of n. But no such data is available, so you can't assume things. So you can just leave it as is. Or what you can do is you can just put it as O of n if m is greater than m is less than n, O of m when m is greater than n, something like that. But this becomes complicated. So simplest way to understand this is O of n plus n, right? So when someday they say that okay, m is equal to n square, then you can simplify it into O of n square, right? But at this point in time, you don't have any data, so this is the best you can do. Okay, so the time complexity here is O of n plus n. Right. So is everyone clear on how we got this O of n plus n and why it is you can simplify it further? Right. Okay. So this piece of code is done. So time complexity is O of n plus m, space is O of one. Right. So we'll move on to the next question, which is this one. So space is O of one. We'll not spend a lot of time on that. Right. So we'll just focus on time in this question. So what is the time complexity of this piece of code? Okay, so I got a variety of responses. Okay, most of them are right. Right. So we'll just take this question, right? So we'll just take this question and understand, given a piece of code, you don't know what is the complexity, right? So, and one more thing, right? Just because there are two loops, you can't assume that it's always n squared. It depends on what all these two loops do. Okay. So we'll see that question next time, but yeah, you get the idea, right? So just because there are two loops, you can't say it's O of n squared, right? So let's just take this example. Most of them got it as O of n squared. It is O of n squared, but how did you come up with O of n squared, right? So whenever you see a question where you don't know what the question is happening, the best way to understand this is, right? But j is going greater than I, right? So j is not always going till 0, right? So yeah, yeah, correct. N square minus n by 2, but yeah. So yeah. So whenever you get any question where you don't know the total number of iterations it's going through, it's better to find the total number of iterations and apply rule 1 and rule 2, right? Because you have all the things in hand, and that is the best way to understand it. The only thing is it is going to take a little more time, but it will be always the best way to understand the complexity, right? So how to find total number of iterations this piece of code is going to take, right? So when I equal to 0, what is going to happen for j? J is going to start at n. It is going to go till n minus 1, n minus 2. It is going to go to n minus 1, n minus 2, n minus 3 until 1. J can't become 0 because j should be greater than I. Since I is 0, j can't become 0, right? So when I equal to 0, how many iterations this j loop will take? So it starts at n, n minus 1, n minus 2 till 1, right? It starts at n, right? So this is going to take n iterations, right? So it is going to start at n and going to go till 1, not up to 1, till 1. Okay. So since n iterations, so when I equal to 1, this j is again going to start at n minus 1, but it is going to go only till 2, right? So how many iterations this is going to take? N minus 1, correct? So this is going to take n minus 1. When I equal to, sorry, when I equal to 1. When I equal to 2, again it's going to start at n and going to go to 3. So n minus 2. So blah, blah, blah. When I equal to n minus 1, j is going to start at n and going to end there, correct? Which means j is going to go only one iteration. So if you add everything, right? If you add this one, n 1 plus 2 plus, so here it will be 2 plus blah, 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 plus n minus 2 plus n minus 1 plus n, right? So if you add everything, you'll get the total number of iterations this piece of code is going to take, correct? So what is 1 plus 2 plus n minus 2 plus n minus 1 plus n? It is summation of n terms, correct? So it is n into n plus 1 by 2, correct? If you want to have, you can have an example. So what is 1 plus 2 plus till 5? 5 into 6 by 2, correct? So it's just 15. So 1 plus 2 plus 5 plus 3 plus 4 plus 5 is 15, right? Same way, it is n into n plus 1 by 2, right? So this is the total number of iterations, right? So when you expand it, it is n squared by 2 plus n by 2, correct? So what is the first rule of time complexity? You can remove the constant terms. So what are all the constant terms in this equation? Right. So this is nothing but 1 by 2, right? 1 by 2 is a constant. So you can just remove this constant. So this is the first rule. So what is the second rule of complexity? Remove the smaller term, sorry, which is compared to n square and n is a smaller term. So you remove it. So what is the only thing which is pending here? N square. So this is nothing but O of n square. So everyone got this answer, but understanding why you, as I said, right? So understanding why you got this, because sometimes in interview what they can say is, okay, explain how you got this complexity, right? In that case, you can't say I have two loops, so it's n square. That's not the right way. You can have two loops and not have n square also, right? So just because there are two loops doesn't mean that what you're doing inside that loop is one, which it matters, right? So yeah. So whenever you want to justify any complexity, this is the best way to justify, because this is mathematics, and mathematics, computer science is built on mathematics, right? So it can never go wrong. So yeah. Any doubts in this? How we got this O of n square time complexity? This is for the entire loop, because for I equal to 0, we are seeing j, right? How many times j is, and we are seeing for all the i's, right? So i's thing is also added here, right? Okay. So when I equal to 0, j will go. We are doing the i's part here, right? So this is nothing but this is total number of iterations. You get the idea? So this is the total number of iterations we got. So what is 1 plus 2 plus 3 plus 4 plus 5 till n? It is a famous formula, which is n into n plus 1 by 2. If you don't know this formula, it is nothing but summation of n terms in an arithmetic progression. So a equal to 1, b equal to 1, a is the starting value, d is the difference between two values equal to 1. So the formula is n by 2 into 2a plus n minus 1 into d, right? So if you remember any of these formula, it will be easy. But if you see this pattern, then you can even note this formula. So 2a to 2a, so 2 into 1, which is 2. N minus 1 into d, d is 1. So 2 plus n minus 1. So what is 2 plus n minus 1? It is n plus 1. Right. So it is n into n plus 1 by 2. Right. So that's why we got this formula. And you can expand this formula, n square by 2 plus n by 2. N square by 2 and n by 2, you can remove this half of, because first rule of time complexity is saying that you can remove the constant terms. Second rule of time complexity is saying that you can remove the smaller terms. So after doing everything, the only thing which is going to be pending is this n square. So it is O of n square. Is that clear? Okay. So I hope it's clear. But yeah, this is just an idea on how, given a code, if you don't know or if you're not really sure, this is the best way to understand the complexity. Right. Okay, so we'll move to the last question, which is this one. So what is the time complexity of this piece of code? Okay, so I got few responses, but yeah, we'll just see. So space complexity is O of 1. Again, not going to spend a lot of time because you have three variables, I, j, 5 variables, and the number of variables is not going to change. Right. So yeah. So yeah. So first thing, before understanding any complexity, we just see this part, right? So in this, are I and j related? Meaning in our previous case, j's, the number of iterations j is going to take was dependent on I. But in this case, is it related? Like the value of I, as the value of I changes, the number of j iteration changes. Right. So in this case, j is having no relationship with I, right? So nothing is going to happen if i's value is changing. Meaning what you can do is you can isolate this piece of code alone and find the complexity and multiply it by complexity of the outer loop. So what is the complexity of the outer loop? It is n by 2, right? So it is actually n by 2 plus 1. But even if you do n by 2 plus 1, it's not going to cause a lot of harm. I'll say why. Okay. So first we'll put n by 2 plus 1. And once you find the complexity of this inner loop, you can just plug it out here, right? And if you multiply this and apply law 1, law 2, you will get the idea, right? So again, coming back. So let's just try to have some values of n and try to see how many iterations this piece of code is going to take, because you want only iterations, right, for time complexity. So if n equal to 2, right, j will start at 2, j will be less than or equal to 2. So the first time it will get iterated. Then j is equal to j into 2. So j will now becomes 2 into 2, 4, right? So, but right now 4 is not less than or equal to n, right? Because 4 is greater than n. So it will stop. So when n equal to 2, there were one iterations. There was only one iteration, right? So what will happen if n equal to 4? When n equal to 4, j will start at 2. J will be less than or equal to 4, right? First time it will get executed. Then j is equal to j into 2. J becomes 4. J is less than or equal to 4 again. Second time it will get executed. J is equal to j into 8, 2, which is 8. 4 into 2, 8. At this point, 8 is not less than or equal to 4. So in this case, it will take 2 iterations, correct? What will happen if n is equal to 8, right? So again starts at 2, goes till 4, goes till 8. But after 8, it will become 8 into 2, 16. But 16 is not less than 8. So it will stop after 3 iterations, right? So n equal to 16. So 2, 4, 8, 16. And when it becomes 32, it will stop. It means 4 iteration, right? So this is the input. This is the input. And output is the number of iterations, right? So this is the output. So what is the correlation between input and output here? Or what is the pattern that is being followed here? So for 2, the number of iterations is 1. For 4, it's 2. For 8, it's 3. For 16, it's 4. It's not double, right? Because 3 into 2 is 6, but it's 8. So it's not double. So what is happening here? It's not square also. 3 square is 9, but it's only 8, right? So what is this? This is correct. So it is 2 power n. Actually, the reverse is 2 power n. So 2 power output is input, correct? It's not 2 power input is not output. 2 power output is input. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. If you have n equal to 32, then it would have stopped after 64 because j is equal to j into 2, right? So it would have been 5. So 2 power 5 is 32, right? So that is 2 power output is equal to input. So what is the correlation between input and output? What is the inverse of power? Right. So inverse of no. Right. So inverse of power is log, right? So everyone knows that, right? So inverse of power is log. So if you take log on both sides, what will happen is log 2 to the base 2 is equal to log of input, right? So what is log 2 to 2, right? What is log 2 to the base 2? It is 1, right? So output is nothing but log of input, right? Which means this is inverse of power, which means the complexity of this piece of code is log n to the base 2, right? So any doubts in this? How we got this log n? So for people who are not clear on what log is, you can just read it out. But to make it very simpler, it is inverse of power. So if you're writing 2 power x is y, then log y to the base 2 is x. So 2 power x is y, log y to the base 2 is x. If you write 3 power x is y, then log y to the base 3 is x, which means 3 power x is y. So this is the correlation between power and log, right?
So if you understand this, then this piece of code is log n, right? So usually if it is base 2, they don't really say it as log, but it's always better to say with log to the base, okay? So it is log n to the base 2, right? If you multiply these two again, right, it is n by 2 log n plus log n, right? So what if you apply rule 1 and rule 2, you'll get n log n, right? Because this half will go away, the smaller term will go away. So the only thing which will be pending is n log n to the base 2. Right. So that is the complexity of this piece of code. Time complexity of this piece of code. Any doubts in this? Okay. So if there are no doubts, then I'm closing today's session with this. Sorry for the confusion initially. I asked them, I also told in the class, but yeah, at the same time remains, we'll start at 9 a.m. Okay. So 9 a.m. I'll tell them to update the portal next time. But yeah, sorry for that. So yeah, with this I closed today's session. So I wanted to cover one more thing, but because of the delay, I was not able to. But no worries. Tomorrow and day after, I'll cover it with extra time, right? So yeah. So with this, I'm closing today's session. Um, what is the purpose of using this? Using what? Complexity to separate out bad piece and good piece, right? Say if you have n square, say if you have O of n code, say if you have O of n cube code, which one do you choose? That is the purpose, right? To find out the most efficient way to approach the problem. You get the idea, right? So that is the main purpose, right? So yeah, and a good way to communicate a piece of code. So how do you say that this piece is efficient? Okay, this is a offense solution. So that's one way to communicate, right? So yeah. Okay, so recursive function, we'll see the time complexity later. We'll see, we will have a recursion separate topic. So we'll see that. But if you really want a formula kind of a thing, there is something called master theorem, which you can look it up on the internet, right? So yeah. So yes, yeah, I'm closing today's session. If you have any doubts, you already have my number, you can ping me there, or you can also ask in tomorrow's session, right? So yeah, thank you for attending. I'll just share the slide link alone. And yeah, so you can just start whenever you solve problem, you know, sit and understand time complexity again. Whenever you solve a problem, take some time and understand what is the time complexity, and you can just go on to solve the problem, right? So you don't have to sit and separately understand this, because it's just a part of your solving, right? So I attach a slide link there, but yeah, I don't have anything. Thank you everyone for attending. Yeah, if you don't have anything else, you can feel free to drop off. Thank you.